Okay, so let's talk a little bit about architectures for scaling quantum networks using satellites. And I think really, the central question that really simplifies it is, I have two ground stations I want to connect with quantum entanglement. They're very far apart. Should I use a space-based link using satellites? Or should I use a terrestrial repeater chain just using fiber in the ground? And here on the figure on the right, that addresses this exact question. Depending on the distance we're talking about, depending on the throughput you need, terrestrial repeaters may be better in some regimes, but in others, satellites are really the way to go. There are different architectures we can consider. So the one I showed a couple of slides ago was showing two downlink architectures where the satellites have the photon sources and they're sending them down to ground stations. You can imagine, a constellation of these satellites in low Earth orbit, where you have downlinks, but also links between satellites, so inter-satellite quantum communication, also ground-to-ground free space optical communications, where we just have, telescopes on the ground communicating directly with a line of sight. And as I mentioned, the quantum internet will be a combination of both free space, space-based links, and terrestrial networks. There is no one-size-fits-all architecture here. It really depends on the application. So the application informs the architecture. The application requirements really inform what's the best link and hardware setup we need. So the application may require a certain coverage. So are we talking about full global connectivity? Are we talking about regional connectivity? If it's, say, an application for a metropolitan region, then we should be fine with just terrestrial networks. But if we're talking about, doing quantum secure communication, from London to New York, then maybe a satellite link is more suitable. So the distance matters, the coverage matters, the key rates will matter. If we're doing something like quantum key distribution, we need to know what throughput we need, what uptime, network uptime we need, and also the cost. So all of these application requirements inform the architecture. But we want to build scalably. We want to build towards this end vision of a global quantum internet. We need to be prepared for advancements in technology. So for example, one-way repeaters. So we need to build these systems with not only the application in mind, but also what we can expect from technological development in the coming years.